guys, and welcome to another video. We have this interesting question right here. 1 divided by 3 all to the power x is equal to x plus 4. And we have to figure out what the value of x is actually going to be. A lot of people would like to use guess and check method when it comes to problems like this. But the purpose of me making this video is how to solve this step by step. So if you're interested in guess and check method, if we guess that x is equal to -1, in fact, on the left hand side, we are going to have 1 divided by 1 over 3, which is equal to 3. And of course, on the right hand side, if x is -1, we're going to have -1 plus 4, which is also positive 3. So indeed, x is equal to 3 is the only real solution to the problem. But like I said, I'm not going to use guess and check method. My aim is to show you step by step on how to solve for x in this equation. Then after everything, I'll show you how the graph of this function right here is actually gonna be. And as always, feel free to pause the video and give it a try first. And if you're able to get -1, comment down below. And if this is your first time visiting my channel, please make sure you subscribe and also tap on the bell notification so that you'll be notified whenever I release a new video. Now, let's get right into it. On the left-hand side of the equation, we can write it as 3 to the power -x is equal to the right-hand side, which is still x plus 4. Now this time, I would like to see the 3 to the power -x as e to the power ln of 3 to the power -x, and still on the right we have x plus 4. And remember, we can move this negative right here to the front here, so that we will have e to the power -x ln of 3 is equal to x plus 4. Now sometimes if you are working with negative powers just like this one, it becomes a little bit difficult. So I'm going to make this one positive by multiplying each side of the equation by e to the power x ln of 3. And remember, in equations, whatever you do to the left hand side, you must do the exact same thing on the right, just like that. So that, in fact, on the left hand side, the bases are the same with different powers multiplying. If this happens, we can actually write one of the bases and then sum their powers. We have x ln of 3 minus x ln of 3, which it will be equal to 0. Of course, we know that any number to the power 0 is equal to 1, with the exception of 0 to the power 0. So let's do that. And this is equal to x plus 4 e to the power x ln of 3, just like that. And currently, this is the equation that we have. But if I'm working problems like this, I always like to move the one that I'll be manipulating to the left and then the one that, I'll be maintaining to the right. So I'll write this as x plus 4 e to the power x ln of 3 is equal to 1. I've done nothing to this. I just brought this one to this side. Cool. Now, the next step is that I would like to make the leading coefficient right here the same as the power right here, so that I will use what is known as Lambert W function. Note this, Lambert W function operates this way. If you have maybe t e to the power t, if we take Lambert W function on this one, we still be getting our t back. In other words, if you have anything at all, in fact, anything, if you have your emoji just like smiling emoji like this, e to the power the same thing just like that. If we take the Lambert W function on this, we still be getting our emoji back. So pay attention, and always this right here should be e always. So now that we know this, I'm gonna get rid of this one really quick and then make sure that the leading coefficient of this right here will be the same thing as the power right here. So how can we do it that way? Check this out. What I'm going to do is that I'm going to keep x plus 4, just like that. Then e to the power x ln of 3. And then, in fact, the right hand side will still be 1. But I'm going to multiply this one right here by e to the power 4 ln of 3. And remember, whatever you do to the left, you must do the same thing to the right. Now, the reason is that we have ln of 3 here, ln of 3 here. We can actually factor it out, so that, in fact, you have x plus 4 times e to the power x plus 4. Then we are going to factor out ln of 3 just like this. And this is equal to e to the power ln. I'm going to move this one to the power right here so that we will get 3 to the power 4, which is the same as 81. Cool. And now we can clearly see that we have x plus 4, x plus 4. ln of 3 is here, but some is not here. We can bring 1 here by multiplying each side of the equation by ln of 3. In fact, if we do that, we are going to have this right here. That is x plus 4. Then I'm going to multiply this one by ln of 3. Then times this e right here, e to the power x plus 4 ln of 3. And this is equal to e to the power ln of 81 is the same as 81, but remember we are multiplying each side by this right here. So we will have 81 ln of 3, just like that. Now let's check this out. The leading coefficient here is the same thing as the power right here. If this happens, we can actually take the Lambert W function right here, then times the leading coefficient here, which is x plus 4 ln of 3 e to the power right here, that is x plus 4 ln of 3, which is equal to w of 81 ln of 3, just like that. Easy. And from what we wrote earlier, that is t e to the power t, if we take Lambert W function on this right here, we still be getting our t back. Therefore, here we are going to have x plus 4 ln of 3, and I'm going to put this in parentheses. Then the right hand side, we have the w right here. I'm going to keep it. Then times 81 is the same as 27 times 3. Then we have ln of 3 right there, just like that. Cool. Now, I'm going to maintain this right here and then move this to the power right here because we are dealing with logarithm. So, as always, we will keep the left hand side, x plus 4 ln of 3 is equal to, I'll keep the Lambert W function. Then move this the way to the power here so that we get ln of 27. Then I'm going to see this 27 right here as e to the power ln of 27, just like that. And the left hand side, we still have x plus 4 ln of 3 is equal to, this whole thing right here will give us ln of 27. And in fact, I can write this ln of 27 just like what we have right here earlier, which is the same as 3 ln of 3. And straight away, we can clearly see that this will cancel out this, and we are left with x plus 4 is equal to 3. Now, if you transpose this positive 4 right here, we are going to end up getting x is equal to negative 1 as the solution to the problem. And like I promised, I'm going to show you quickly how the graph of this function is actually going to be like. So quickly, I'm going to get rid of this one and then show you how the graph is actually going to look like. In fact, if this is our Cartesian plane right here, let's say this right here is 4, this is negative 4, just like that. In fact, if we set this one right here to y, we are going to get something like this. In fact, it's a decreasing function which is asymptotic to the x-axis. Then, right here, if you set y2 to be equal to the right-hand side, x is going to be negative 4, and then y is also going to be positive 4, which will be just like this. It will pass through the negative 4 straight to the 4 like that. And this right here, if you trace it down properly, this is going to be the negative 1. So this is how the real one is actually going to be. So guys, that is pretty much it. I hope you found this video useful. If not anything, don't forget to subscribe, like, comment, and share. Also, check out this video or this one as well. Of course, see you again on the next video. Thanks for watching. Take care of yourself and bye-bye.